a couple of news items I thought were sort of noteworthy, my astronomy news reading is pretty focused on the things that are interesting to me. This is one I kind of like, right? This is an object that has been at least known for quite a while. And now they sort of have realized that it's perhaps not an asteroid after all, it's a comet. And the way they realized this was that, I don't know, Gary, you probably followed this a little bit. I mean, they were going to try to follow up on it, and they point and not find it. And that to me seems like a very common experience because all the light fall into that boat a lot. But it turns out that they did recover it, not in the same place, and not in its particular location. And so the conclusion that they drew from this is, comets have these volatiles on their surface, and when they warm up, they shoot little jets of this stuff out and can actually change the orbit of it. And they figured that something like that must have happened, so they reclassified this thing. One of the things that made me sort of muse on or ruminate on when I saw this is, I always used to feel like I kind of knew what the difference between an asteroid and a comet was, and I sort of feel like, I don't really have quite a good, I always thought that comets were volatiles and asteroids were rocks, but now it's maybe a little less clear in my mind. One of the other things that was sort of an implication for all of this was that this could complicate some of the planetary fence, or at least provide a wrinkle to that, because so much of that depends on recovery of objects or understanding their orbits well in advance of when there might be a problem. And if they're moving around out there, if there's something that, other than just Sir Isaac Newton figuring out where they're going to be, that complicates the process a little bit. So this was kind of a little article, but I thought it had kind of an interesting.
Was the reclassification based upon the assumption that the orbit changed
because of something to do with, it couldn't be accounted for simply by calculating its position using, gravity, basically.
Another possibility to this is asteroids do get hit by other asteroids occasionally, and they leave a stream, usually a very narrow stream of dust particles. And with the comet, that's what's all over the place. But when an asteroid gets hit, it ejects a stream, and the particles are very thin line.
Do you know if that's been observed with this one? The article I read, which was a popular article, it wasn't a science paper, no mention of that one way or the other.
Right, but I've seen that happen on at least 3 different occasions when I was doing a follow-up on other asteroids.
So you could actually see the
Yeah, you see the stream. Exactly right.
When they did the DART mission, it produced a pretty observable stream.
Well, you're right.
Yeah. Speaking of which, I did not get a capture for this, but the Chinese Space Agency is going to do an intercept similar to the DART mission, although this one will not be a double asteroid. Actually, one that's a single asteroid. So,
Yeah, they're in Arizona.
maybe Arizona. Well, based on my experiences in Arizona,
What do you know?
actually, that's not true. I do kind of like parts of Arizona. But anyway, so that was one article that I thought was kind of interesting. Another one that I thought was very interesting was this one. I don't know if any of you have seen this, but when I first saw the headlines on this, I knew that there were groups that were looking for moons around exoplanets. And so when I first saw the headline of this, it was like exoplanet moons discovered. I thought, oh, that's pretty cool. But then you start reading through the article, and it turns out it's this unbelievably weird situation where what they originally observed was an object like a gas giant, basically, but it was in orbit around a brown dwarf, which is sort of like this weird thing that's sort of halfway between a gas giant and a star that didn't like make it, basically. But then that whole thing was in orbit around a star. So it's a moon of a moon of a star. And it's just this monumentally strange thing that nothing like this has ever really been observed before. So they, astronomers that did all this were interviewed on this, and they were just basically kind of shaking their heads at what a strange object this was. So, but I thought that was a pretty interesting thing, and it kind of one of the people that worked on this sort of commented that it really it makes the whole definition of what a planet and a moon are even more complicated than they already were now, because now you have this thing that's, how do you classify an object? It would be a little bit like Jupiter being in orbit around something kind of like Jupiter, about 8 times bigger, around a star. So, very odd situation. Anyway, I thought that was I was actually listening to a podcast on the way here that called Astrium or something like that. It's one of these astronomy things. I think it's from Australia, based on the accents of the people that are doing it. But they were talking about the Planet Nine and how they, the possible arguments in favor of there being a Planet Nine and the ones that are not so much in favor of it. It just kind of goes to show you that these things are, in some ways, trying to do definitions is like, trying to nail jello to the wall, basically. It's such a fluid situation, that it's very hard to really meaningfully define these. Anyway, that was one that kind of caught my eye. So this is one, actually this one, and this one sort of popped up within a few minutes of each other, which I thought was an interesting thing because they're unrelated to each other, even from a different source, but they both deal with precious metals. And one of the things I was thinking about doing a general meeting topic on this. Gold as a metal is unusually prevalent in the Earth system. That's not to say there's a whole lot of it, but there's more of it than theory would predict, right? And theory would predict that most of the gold would have been formed probably in either a supernova or some kind of cataclysmic event, right? And would end up in the core of the planet, so it wouldn't be available for mining. It would be way down, because gold is a siderophile, it lights on here, most of all on here. And so a lot of the gold apparently that is mineable is from meteorites. They were speculating, and that those in turn might have formed later from different processes. So this was one where they're kind of suggesting that neutron stars, a nearby neutron star, a magnetar, which is a type of neutron star that has a really unusually powerful magnetic field, may have been responsible for the fact that there's so much, relative speaking, or at least compared to what theories suggest, there's more gold on Earth than there should be. So I was just kind of struck by that fact because it seemed to be a really interesting linkage between these, astrophysical events going on billions of years ago and something that is a part of our everyday life.
If I remember it, the primary mechanism by which gold was created in the universe is through neutron star mergers.
Yes, and they were talking about it must have been 1 year to the Earth about the time that the solar system was formed. Yeah. Mm-hmm. And then the silver one was there's too much gold on Earth. They couldn't find the silver that it should be in the sun. Not that it wasn't there necessarily. Again, it's just trace element, not very much of it there at all. They actually kind of found that it it is there. Actually, it's just not in the way that, it wasn't apparent in the way that they were looking for. But I guess these precious metals, these things that we find here on Earth that kind of formed, on these processes. To me, that's always just been a super interesting thing, all this stuff we see around came about during these processes that happened long ago, and there's these titanic forces, basically. So I thought those are interesting little news articles. So, I do want to talk about one other thing. I kind of drifted away from doing the focus on sessions here because, frankly, I was running out of constellations to do. But I wanted to talk about something that has come up in a number of different contexts. So I wanted to just talk a little bit about it. And that's something that I'm sure we're all more than aware of. And that's light pollution and the issues associated with light pollution. Gary, you said you're going to talk to us here. So I thought I'd do a little bit of a focus section on light pollution because it's obviously something that has been a major topic for us lately. The whole program that we've tried to undertake to move the tunnel is largely due to changes in light pollution. There's been some newsworthy events about that. But the other thing that a couple of things that sort of precipitated is, one was a question was asked actually at ASTRO today, which at first glance, the question, I don't know, Gary, what you thought of it, the question sort of confused me because the question was, how long does light pollution last, or something like that?
Yeah.
And, so it made me think that, well, here's a person that's at least a little bit of, has interested enough to ask a question, but maybe not understanding the fact that this is not like a smoke or something that just sort of lingers there. But that kind of made me think that perhaps the idea of around light pollution aren't as publicly known. Obviously, we're all more than aware of it. The other thing that really set it off for me was I got a copy of this book actually from my anniversary, which was a little while ago. It's all 10th. And it's called The Wild Ark. It's by Craig Childs, who's one of my all-time favorite writers. He mostly writes about the southwestern U.S. He wrote one of the most amazing books I've ever actually written called Sense of Water. And one of the blurb on the front of that book has stuck with me ever since because, number one, I love deserts. And I teach about them in my classes. And on it says the two easiest ways to die in the desert are to have thirst and drown. And it's very much about how water works in arid environments. So again, it's a really extremely interesting writer. But he wrote this book called Wild Ark, which is a very thin little book. I read it in one sitting, where he and a friend of his, subtitle was Finding the Night Sky in the Age of Light. And he and a friend of his, and I don't know if you had a chance to read that.
Yeah, I got my copy yesterday, and I started reading it last night, I fell asleep, before I did, I tell you, he's a good writer.
Yeah, he's an excellent writer. But what he does, he and a friend of his, I'm not spoiling it, but they start on bicycles in Las Vegas at the Sphere, that weird ball-shaped whatever the hell it is that they built there, which is brilliantly lit up, right? So he's in the middle of Las Vegas in borderline skies. And then they start riding through, so one chapter is borderline, the next chapter is borderway, all the way, and he ends up at a dark sky side of Utah, which is border one. And at every point along the way, he kind of talks about what you can see and gives his impressions on it and stuff. So I don't know, I found it a super interesting book. I don't want to make you think I'm his agent or anything, but if you're interested in just a really easy read about this is really cool. But it also kind of got me thinking a little bit about light pollution. This is the other thing I was thinking about. I don't know if you all heard this little bit of news, but this is a startup company, I believe, somewhere in California, that their intention is to build large mirrors in space. And the idea is that they can actually beam sunlight down to places where it's not. I'm not going to lie, I think this is absolutely horrible idea. website, but they seem to be convinced they're doing Manatee a great service by this. But anyway, there's a proposal eventually. The first one of their satellites has been approved for launch and may possibly be launched this year. So one of these things may be awarded by the end of this year. At one point, their plan is that their ultimate plan is to really put thousands of these things.
50,000 or
50,000 of these things. So, I mean, I'm not.
It'll be a 3 mile long beam.
Yeah, it's a 5 kilometer beam of light. So this got me thinking about, my experiences with the night sky and nighttime, and which may seem like, what the hell does this picture got to do with that? That is the house I grew up in, and that rock that you can see in foreground there was where I would go out at night and lie down and look at the sky. So a lot of my early experiences of looking at the sky were laying on that rock right there. And this is in Colorado. This is in Estes Park. At the time, I was living in this house, which should have been mid-70s, mid-70s. It was pretty dark there. This is a place. This would have been off. I don't know if you've ever been to Estes Park, but if you go down the main street of the town, California Avenue toward the west, our house would have been on the left side. Would have been looking off to the south. And then this would be looking up to the right. This is a rock formation that's on a big, called Lumpy Ridge over there. Climber's Paradise. This is where I went to rock climbing and spent so much time rock climbing there that I just barely managed to graduate from high school. So this is a formation called the Twin Owls, which is literally framed by my bedroom window. I could look out and see. Anyway, and it looked, this is a little bit of an exaggeration, but it looked a lot like this. It looked very, very clear, and you could see stunning amounts of detail. Now, if you look at what is there now, this is a light pollution map. This is one of those maps that you're probably familiar with. For the Front Range, right? So Estes is right there. And that's a little blob, basically a 4 to 4-ish sky. So it's basically the same as,
My backyard.
your backyard. And so it sort of drove home the fact to me that even in these places we think of as kind of pristine and dark, and it's not. We're kind of rapidly losing the night sky and all the things that sort of go along with it. And, I think we mostly look at this from an astronomical perspective, right? Because that's what we do, right? That's what our interests are. And we think about. But there's so much more to it than that. Wildlife biologists are some of the strongest advocates for maintaining dark skies because a lot of wildlife biology depends on it. Nocturnal animal life cycles, migrations, all these things depend on it. Some of the I could bring in some of my ecologist studies who could talk on this until literally I just shut them off. About the significance of bird migrations are super affected by this. Even other things you wouldn't think about, like pollination patterns in plants, which are crucial to maintaining plant ecology, all affected by light pollution. So we as astronomers and people interested in looking at that night sky, we certainly feel like our skies are affected in that way. There's way more to this than that. And there's significant impacts on humans too. This is one of the things that I always find a little disconcerting is oftentimes lighting is sold as a safety thing, right? That let's make the environment safer by adding light to it. And in a sense, it probably does. I mean, there's certainly, I would say, an inverse relationship between lighting and certain kinds of crime, right? But on the other hand, there's significant direct effects on humans, right? Some things I wouldn't even have thought about. Cardiovascular diseases are positively correlated with light pollution. Now, that could be a case of they're both correlated with something else, right? You always have to be a little careful with assuming that the correlation between two things is positive, right? That's a kind of a classic mistake that you make in data analysis, but it's still pretty indicative that these things are related. Diabetes, insomnia, mental stresses, all of these things that are real problems, really affect human life, are pretty closely related to this. So the numbers on this thing, and this is actually from a Climate Watch study. About 80% of the world's population is affected by pollution, and about 99% of the, I don't know, maybe developed world, USA, Europe, all deprived of natural light. And again, you don't have to get too far into a city before you really can't see much at all out there. So I think this is much more of an issue than is realized. And that kind of naive question that a woman asked about how long was light pollution last. I mean, there's a lot more behind that question than you might gather at first. So this is the changes, right? This is, some of this is reproduced data. Some of it's actually measurements that are made from space. But look at that. This is late 1950s right here, right? But by the time, there's the mid-70s, this would have been about the time I was laying out in the backyard looking at up the sky. Look at it now. I mean, this is just startling how much this has changed in the space of 60 or 70 years. And of course, it's pretty closely correlated to population increases. There's more people than there used to be. But I think it's also related to the fact that people are simply just lighting more and lighting differently. Like the types of lights that are being used are different. And I think we see this even in the relatively short amount of time I'm going to have to far away. You can see the difference. LED lights.
LEDs is a significant portion of that.
And LED's light spectrum, they're not just brighter, their light spectrum is wider, right? So they're affecting regions of the spectrum that, like incandescent lights, didn't really affect nearly as much.
Being cheaper to operate.
Yeah, they're cheap. Yeah.
Install
Operate and have an output that's higher.
Yeah. So, I mean, from a lighting perspective, they're great. The problem is that, you put one outside of your barn or your house or whatever, and you're lighting up a lot more of the sky than you might realize. So light pollution's been a problem for quite a long time, and there have been places that have been pretty popular, like the city of San Diego actually includes all their street lights because they're close enough to the Palomar Observatory, and the Palomar observers actually kind of sort of back in the 70s, probably maybe a little bit, actually went down to the public meetings and said, hey, can we work together on this? And they did. So, I mean, there have been notable cases of dark sky communities that have been very cooperative on this, but for the most part, it's not that I think people are uncooperative, they just don't know about it, right? They just don't realize that light really does go up as well as down. So, anyway, so this is not a new problem by any means. But the addition to this of this whole business with Reflect Orbital, which is the company that is planning on putting these, adds yet another dimension to this that I again think is just unbelievably bad idea. So here's a picture. This is some of the people that worked at Reflect Orbital. They look like nice people, just won't hate on them too much, but this is the mirror in the foreground there. These things are big. These are not small by any means. These are very large reflected elements that'll go into orbit, and they're very much in an advanced state of development. This is not just a drawing board idea. This stuff is, it's an advanced state of development. The idea is to put these things up into orbit, and then basically for a fee, you can have light beam down onto whatever it is you want to have light beam down on. They've kind of, one of the things that they frequently mention is using it to illuminate solar arrays. arrays, right? So solar arrays obviously don't work at nighttime. So the idea would be you illuminate a solar array. I did I don't know, this is not, I'm not going to say this is definitive, but I kind of did a little back of the envelope math based on how reflective I thought some of these things were. And I didn't get a whole lot by the time they beamed it through the atmosphere, which, typically is going to take out about half the signal, right? Just because that's what happens to light when it passes through an atmosphere. It did not seem to me like it was going to generate enough additional electricity to make it worthwhile, because they're talking about thousands of dollars an hour to do this. But I don't know, maybe people who understand this stuff better than I do have kind of worked through that math a little better than I did. But it was seemed a little sketchy to me. But this is the basic idea on this. This is one of their publicity photos. I think they might have done a better job of picking something to illuminate that golf course. If you really wanted to, make a case that you're going to seriously benefit people by this, allowing people to play golf at night. I'm not a golfer. I've golfed once in my life. I hit the ball into every hole, and I figured, okay, I did that. But so I think they may have chosen a better example for this. Anyway, this gives you an idea of what this might look like, basically. Here's some of the here's for astrophotographers and astronomers here in the foreground being blinded by this bright beam of light coming down, which, by the way, could be a hazard in and of itself. One of the hazards maybe associated with this is, if you're an airline pilot and then all of a sudden somebody turns one of these mirrors on and you fly through the beam, it could affect your vision pretty thoroughly. So I think there's certainly safety issues to be made. And again, somebody mentioned the number of satellites they're thinking about. They want to put 2 in orbit by the end of this year, which is what, 5 more months, 6 more months. So we need a good move on. 36 by the end of next year, 50,000 by 2035. And think about that. 50,000 big, bright, shiny, huge satellites in a space that already has thousands, tens of thousands of satellites up there. I don't know, every time we try to image something, you expect now to get a satellite, right? So, how much is too much? How many satellites can we put in orbit before there's no room left? What's the thing that affects that first in the row where one of them goes kind of a little off and hits another one, and now hits another one, and pretty soon you got this massive collision fest going on, and you think, oh, great, that'll get rid of all those satellites. It really won't. It just turns them into piles of crap.
Well, no, it's different, more small pieces out.
Instead of making big things, you've got this payload of junk, basically. Of course, on the plus side, there's been at least one country so far, Canada, that has indicated to Reflect Orbital that they will not allow Reflect Orbital to shine light on their territory. I certainly hope so. To me, that may be the most effective way to stop this, is to take away the market. So, anyway, so again, the first one of these things did get, this is kind of a busy little slide here, but the first one of these did get approved just not too long ago by the FCC, whose argument was that they just do communications. They don't anything at all to do with bouncing light. So they claim to have no jurisdiction over this. I honestly don't know who does. Apparently it's just the Wild West up there.
Theoretically, the UN does.
Well, the UN is trying to develop regulations.
Yeah, and if they could come up with giant nets basically to get these things out of space, but that's anyway. So the big question, and one of the reasons why I threw this in here, the big question down here, at the bottom, can space mirrors scale responsibly? And I actually think there's an even bigger question here, which is, should they be up there in the first place? And to me, there's a pretty clear answer to that. No, but I think as people who are interested in this, and I think to a certain extent advocates of all this, we do need to kind of be a little bit in the educational realm on this, getting the word out that, you know, this is a potentially very, very bad idea. And one of the organizations that's a leader on this is Dark Sky International, which I know a couple of us belong to, but Dark Sky International did submit a petition to the FCC to deny the reflector orbital permission to launch the first cell. I sent it. Apparently none of us did no good. The four of us, you can't imagine if the four of us is not enough.
Yeah,
I mean,
it's hard to imagine that, was not enough to make
Yeah.
that stuff.
But anyway, it didn't work. So they had over 10,000 signatures, which, you know, anyway. So, but they're still advocating for this. So, you know, if you want to, you know, if you got a spare change that you're not using, I think this is a good organization.
Dark Sky also has an advocacy program that is open to members to join.
Yeah.
It's a kind of grassroots movement within Dark Sky. We have monthly meetings.
Is there a Dark Sky Kansas?
Not that I know of. I'm one of the few advocates, members of the advocacy group.
Or maybe it's, you know, time to see if we can
Yeah,
get
well,
on together.
we could be good.
There was a Dark Sky Oklahoma had a booth at the Missouri meeting in St. Louis just this past, a few weeks ago. You know, this is something I, you know, as much as I'm kind of my native tendency is not to be out there carrying signs and, you know, protesting and that sort of thing. This, if not us, then who? You know? So, anyway, so that was just a little bit of
Dark Sky chapter again this one.
I wonder if it would be worth like paying the club in Kansas City and maybe some of the others. And I know they're mostly they consider stuff in Missouri, but
Missouri and Nebraska have one.
do they program one? So maybe they're still. But
Yeah,
Payne Wichita Group, see if
Paying Rick Cashman.
yeah. See if we can sort of get a shot to do it.
Carolyn's,
Oh, yeah.
Who is it?
Carolyn,
Jeremy?
Yes. Mm-hmm.
Yeah.
There's also a group out in Hayes.
Yeah, I've heard about them. Well, I would say maybe it would be worth our while to sort of put together some kind of communication with them and say, hey, you know, all our neighbors are doing this, maybe we should jump in there. That's all I really wanted to say about that. Again, I was sort of inspired by this book, so if you ever want to read it, highly recommend it. Okay. So, David, you're up.
Okay.
So let's That's a very blurry picture because I grabbed it off your website, I think.
There we go.
Do we need to get this out of the way? Are you down here?
So, I don't have the power on it.
It's in. Looks like it's PDF.
Yeah. It must have opened and.
So it's in the middle. Okay. See, I don't see the slideshow.
Yeah. I don't really use.
It's in view. I don't know. View maybe down there. Full screen mode.
everything. That's what I'm looking for. Okay. That's a picture of Mariana birds. This is a presentation that I gave to the Space Fest conference in the University of Kansas back in May. And basically, I've only kind of added just a little bit to it since then. This is going to be a rather short presentation. It was limited to 15 minutes for the conference presentation. But, okay. My interest in Mariana bird started back in 2020 when I was adding a book to my library. I picked up a copy of Laboratory Manual of Astronomy by a Mariana bird. I had never heard of her, never seen this book, but I picked this book up off of eBay. And one of the things I do when I add a new book to my collection is I'll enter it into my little Access database, and I always like to add some author information to the database. And when I looked up her information on Wikipedia, it said that she died in Lawrence. Wow! Here's somebody an astronomer, who apparently lived in Lawrence and died in Lawrence. And I asked around, I asked some of the astronomers, some of my fellow astronomers in Lawrence, they had never heard of her. And so I thought, okay, let's dig into her, find out more about her. And first thing I did was I had to find the grave. And here's the family graves cemetery site in Oak Hill Cemetery over in Lawrence. She had like 8 brothers and sisters. Four of her siblings, besides her, including her, are buried there in Lawrence. Her parents are also buried there. Her parents moved to Lawrence, to the eastern Kansas, northeast Kansas, from Michigan in the 1850s. Well, actually, she was born in Leroy, Michigan in 1849, and I had to do a little, figure out which Leroy, Michigan they were referring to. Historically in Michigan, 2 towns with the name of Leroy. Well, yeah, I did finally find, through searching through things and help from the people who do the tax, they have access to the tax records up there, that she was born in East Leroy, which used to be called Leroy. They lost their post office in 1876, and a new town of Leroy was founded in the same year. So that was the first thing I had to clear up. Which town was she born in? Well, the family moved to Leavenworth in 1855, and her parents were abolitionists, where they operated a safe house on the Underground Railroad there in Leavenworth. The family resettled near Lawrence in 1874. Her uncle, David Lowe, that is her mother's brother, was a territorial judge in Kansas and served 1 term in Congress after his statehood was achieved. And let's see. Oh, her parents, or particularly her father, Reverend Bird, he was a congregational minister, suffered physically a lot from his stance on slavery. Often beaten up, pretty badly beaten up. Now, Mary's education, she graduated from Leavenworth High School in 1871. Now, it was, if you go to the Leavenworth High School website, they don't acknowledge her as a student, but on the Kansas website that promotes Kansas things to do, they mention her being a graduate of Leavenworth High School. She attended Oberlin College where her father had received his degree. She attended Oberlin College from 1871 to 1874, but she never finished. She transferred to the University of Michigan, where she graduated with a BA in 1878 in astronomy. Then, later she studied astronomy at Harvard College Observatory under Edward Pickering. Edward Pickering is the astronomer who had all the women computers. She studied 1 year of astronomy between 1882 and 1883. And this was a kind of a critical year for her. It really, on working under Pickering, she was able to get good references from Pickering, and later in her career she received an honorary PhD from Carleton College in 1904. Now in her career, after after graduating from high school, she was principal of Wabash High School in Indiana from 1879 until 1882. And interestingly, Wabash High School, when I was first starting my research, did not acknowledge her as being a principal at their high school. But now they are. So,
Because of you?
I don't know. I sent an email to the administration asking if they had any information about her tenure there. Never replied back. Of course, this is the beginning of the COVID epidemic, and I wasn't getting a lot of responses from anybody on the inquiries. Now, in 1883, because of her she was principal of Wabash High School after her graduation from the University of Michigan. And then she spent 1 year at Harvard. And after that, she went to the Goodsell Observatory at Carleton College in 1883, where she was responsible for maintaining the observatory's time service for the railroads in the northern part of the United States. There she also taught mathematics and astronomy. In 1887, she was appointed director of the Smith College Observatory, where she held no academic rank. Now, the Smith College Observatory in 1887 was brand new, and her primary task was to get the observatory up and operational. And during that time of making the observatory operational, she gained a lot of new knowledge, which she used in publishing her first book, A Laboratory Manual of Astronomy. Now, in 1906, she resigned her position at Smith College because she objected to the college receiving money from Rockefeller Foundation and also from Carnegie. She considered money from the robber barons to be tainted, and she would not have anything to do with that. For parents, it was kind of a common belief among certain groups like the congregational people that robber baron money was tainted, and that she was kind of following what her mother and father had done. Here are a couple pictures of her at Smith College. This picture on the left is a picture of her with a daughter of a friend of hers. And on the right is a picture taken in the transit room at Smith College, the transit telescope, with some of her students. This picture on the right is one that I was sent to me by I'm drawing a blank. He's a member of Dark Sky International. He's the chairman of the astronomy department at Smith College. I'm drawing a blank. That'll come back to me at some point. Now, when she resigned from Smith College, this was a big deal. It was carried, the news was carried in just about every major paper and minor paper in the country. And this is just a couple of examples. Brooklyn Eagle mentioned it, Wichita Eagle, World News in Roanoke, Virginia, all of the Boston papers, New York papers, basically everybody covered it. So it was a big brouhaha.
Apparently, we have the same philosophy at Farmland, because we don't get any money.
Now, here's a Boston Globe, an excerpt from the Boston Globe. Miss Bird is a woman of intense convictions, and taking a stand for conscience sake is in the blood. And she inherited her moral convictions from her parents, who stand against slavery and active participation in the Free State movement, made him a frequent target for physical violence. After her resignation, she came back to Lawrence, where currently the Bishop Seabury Academy is now located. I did a little searching through state records, particularly through aerial surveys of Douglas County, and was able to locate pictures of the family farm taken in the 1930s. And if you look on, from one of her books, the book First Observations in Astronomy, pictured here, she explains to her readers, how to determine one's longitude and latitude using a symbol on the transit instrument. And she works through the example of finding the longitude and latitude of her family farm. And I took those coordinates, looked them up on Google Maps, and said, ooh, that's right where Bishop Seabury Academy is now located. So, after returning to Lawrence, she began writing her second book, First Observations in Astronomy. And so from 1906 through 1913, she resided in Lawrence. She left Lawrence to take a position for the Normal College of the City of New York in 1913, where she completed the book. And then she returned again to Lawrence in summer of 1914. And she did some independent research at the Cave Observatory in the summer of 1920. And she did some observations of Winnipeg's comet with Dinsmore Alter in 1921. That's documented by the University of Dale Kansas of that time period. They ran an article about Bird and Dinsmore making their comet observations. Pardon? No, with Clark telescope, 1921. This is before the 27-inch. She also did some astronomy outreach in Lawrence. There were some newspaper articles in the Lawrence Daily, Lawrence Journal World, where they announced, some public observing sessions after public lectures. She had a lot of memberships. She was a member of the American Astronomical Society, Astronomical Society Pacific, British Astronomical Association, American Mathematical Society, the Anti-Imperialist League of Northampton. The Anti-Imperialist League was a group that opposed the annexation of the Philippines. So she was an active member of that group opposing the acquisition of the Philippines by the United States. She was also a member of the Society for Practical Astronomy. I had never heard of this group, to tell you the truth. I had to look this up. And I actually had to do some digging to find this reference, that she was a member, because when I was searching through the literature, I found a reference in the Astronomical Society Pacific publications of her doing some work with this society Society for Practical Astronomy. And sure enough, I was able to find more information about when I knew what to look for. This society was a forerunner of the Astronomical League, kind of a failed attempt at a national astronomy group for amateurs in the United States. It was a very short-lived organization. It only existed about 9 years. They had a fairly hefty journal of well over 100 pages each month. So basically she was provided for this amateur group, she was providing astronomy education for the amateurs who were members who joined the organization. She has I've listed all of the publications I could find that she made. I've got about 3 screens of publications here. A lot of, she did have some professional observations that she published. Her primary professional interest was comets. And she has made a number of comet observations that she published in the Astronomical Journal and one of the German journals. She Lawrence Journal World ran an article that she wrote about Daniels' comet in 1907. So we've got 2 textbooks that she listed here. One of her biggest publications was the Longitude of the College Observatory, which is published in the Annals of the Harvard College Observatory. She co-authored with Mary Watson Whitney. This is a fairly long, very detailed article about determining the longitude of the Smith College Observatory from using the Harvard College Observatory as a reference. So they determined the difference in longitude and latitude between the 2 observatories. And a lot of mathematics, a lot of observations in mathematics went into making that determination. Here's here's an example of one of her published comet observations. And you can see she was using the Smith College 11-inch refractor and a 500 micrometer. So these are all visual observations, determining the right ascension and declination of the comet and the while she was living in Lawrence, she wrote a long, while she was at Smith College, she wrote a number of educational articles in a amateur publication called Popular Astronomy. Back in the late 1800s, early 1900s, right up to the 1950s, there was a astronomy magazine called Popular Astronomy for amateurs by professional astronomers. And she wrote a number of articles on astronomy education. Right on from the time she was at Smith College, right up through her stay in Lawrence, up through the 1920s. Her very last publication was a meteor observation that her sister had made that was published in 1930. After basically 1921, she retired and moved to Florida. Here are some of the publications, her articles that she wrote in the Society for Practical Astronomy for their journal. Initially, she wrote a plea for a new section in the group for the education of amateur astronomers. and then it was a, basically updates on the progress of the group, of the session. She was basically running a correspondence course for amateurs from her home in Lawrence. So as I said, after she retired from astronomy, she also did some Russian relief efforts in 1922 while she was in Lawrence. Left Lawrence in 1922 for, I can't remember how to pronounce that in Sydney, Florida. Her move occurred after the death of her older sister Abby in 1922. She returned to Lawrence in 1930, published a single article about the meteor observations by her sister Alice, and she died of cerebral hemorrhage in 1934. Now, I did find some newspaper articles when she was in Florida. She did actually do a public talk in Florida, but that, to my knowledge, that was the last time she gave a public talk. And this is just some table of contents from her laboratory manual in astronomy. Those of you interested in astronomy education, this is kind of some of the things that she covered in her first book. And more of the contents. When she was at one of the things when she was at Smith College, she had her students out observing, but on every clear night possible, and they would come in and spend time indoors and reducing the observations. And basically, the Smith College Observatory was active all the time. There was always basically something going on at all times. And some acknowledgement. James Baldwin, that's quite the picture, the one picture from. And I also received some other pictures and other materials from the Smith College Special Collections by request. And some other references. Any questions?
So she remained obscure for a long time.
Yes, she remained obscure in Lawrence until I made this presentation in May.
That's pretty cool. Big guy out.
I've got another thing that I'm working on. There was a optician in Wichita who helped Clyde Tombaugh in his first telescope year.
He coded it, right?
He did coding of it and criticized, critiqued his first attempt, which was a total failure.
There was a novel I read once called Percival's Planet. Have you ever read it?
I haven't gotten around to reading it.
It's about Clyde and everything, but it mentions that part of it is that he sent his mirror out of this guy in Wichita. So it's mentioned in this novel.
And the guy's name is, I'm trying to remember this. Napoleon Carrera is the name of the Wichita optician. He was an optometrist and an optician. So he was the local eye doctor, one of the local eye doctors in Wichita. And he made the lenses for his own patients. And he made optical instruments to boot. He made telescopes, he made spectrographs. I don't know if he made microscopes, but he made a lot of optical instruments. He was a very good optician. Had a little optical factory there in Wichita. But I've tried to contact people down there, and nobody knows,
Well, that would have been,
nobody remembers anything about
that would have been 9 years ago almost.
it. Yeah.
The tomahawk round is in the last city.
Yes. And Napoleon Guerra critiqued his first attempt and provided ancillary services for his mirror.
Cool.
That's another presentation I'm going to throw together for Space Fest. It's coming next year.
Yeah, that sounds like a good one.
Okay, one more. Let's see. A little bit of, let's see. Kuiper Belt objects with a sea star.
Okay.
Earlier this month, I decided to try imaging Pluto with my Sea Star S50.
Mm-hmm.
Turns out it's a fairly easy target with the S50.
Now, did you do this from your home?
Yes, backyard, it's a portable 4.5 star.
Mayor.
And
Right?
come on.
Yeah.
Okay, there's a stock picture of an S50, 50mm lens with a Sony color sensor. And,
You know which one?
the ICX 4 something, 468 or 486. I don't remember the exact order of
Yeah.
the numbers.
There doesn't seem to be other obsolescence.
The quantum efficiency of that sensor is like about almost 90%.
Yeah.
It's real high quantum efficiency. So I started with Pluto, brightest of Kuiper Belt objects, about magnitude 50 right now. And it's also present in the CSTAR solar system list. If you go to the solar system list and click on Find Pluto, it takes you to the imaging screen, which is same thing that's used for the moon, the sun, and other bright planets. Totally useless for Pluto. Okay, whoever did the ZWO who developed that screen is like, they never observed Pluto before. So this is what I had to do to get Pluto. I used their Pluto list item just to center, just get it there. Then I backed out of it to their site atlas. And so the sky atlas showed me where it should be located, where it should be located. And then I just clicked synchronize, and then go to, and I was at the image capture window for deep sky imaging. And I selected a 30-second exposure time, and it captured images from about almost 50, I was around 50 images.
I'm curious, what was your rejection rate on that? You know?
Oh, it wasn't very high on the 30-second exposure. Rejection rate I found has a lot to do with the slop in the drive. If you look at a stack of all the subframes from the session, you'll see the object moving back and forth. There's a very high amount of periodic error.
Plus it's got minus 20 declination, which adds to that.
Which does add to that.
Yeah.
Farther north you are, the less of a problem it is. So the main problem with rejected frames of the sea stars, poor polar alignment, and just the sloppiness in the drive.
It's true of what I just said.
Yeah. And on the mornings of July 15th, 16th, and 17th, I got 3 successive nights. And the two on the right, pictures on the 2 on the right, and 16th and 17th, those are ones that I did some enhancement to. One on the left, and the 15th, No, there's no enhancements at all to that. Now, oh, come on, it's- okay, it doesn't want to play.
I was having this trouble too.
Okay, I have to dive out of this. Where's the original one? This the browser. Off we go. There we go. When I did the animation, I just took raw, unprocessed images. Well, the only thing I did to the images was stretch them. I just applied a stretch so that you can actually see the image and the fit. Stretch that fits follows. So 3 successive nights, pretty bright. This is a cropped. These images are cropped from the original, but you can see it's fairly bright. And
That new moon week was the first new moon week I think I've ever seen where every night was clear.
yeah, that was good to get. I was pretty happy to have those 3 clear nights. Right on the
software.
What's that?
Can you imagine telling them all about the software?
He was doing the old manual blank.
Yeah.
They didn't have whitewash.
Nope. Now it's working. And it stopped. Okay. If you want to know how I created the animation, I loaded these FITS files into the Deep Sky Stacker. And, oops, put my quotes, double quotes on the wrong place. Set the Save Registered Frames option from the Stacking Options dialog. If you don't set that option, the individual registered frames are not saved in the finals after the final stacking is done. I wanted to have the individual registered frames to import into to my image processing when I have into the GIMP. So I loaded these registered frames into the GIMP, created an empty image in the GIMP, and loaded the registered frames as new layers and into the empty image. And I sorted the layers appropriately, changed the transparency of the layers so I could align them, and then just crop the image and save it as an animated GIF. And then you export it from the GIMP, and when you select the GIF as the export type, you have to check Save as an Animation. Now, the other night, this last week, when the crescent moon was still in the was up, I made an attempt to do Haumea. It's magnitude 17.3, with the air mass figured in closer to magnitude 18. This one, since Haumea is not on the object list, I had to kind of manually try to center the camera so the telescope on its position. And I was using some coordinates that are a few days old, so I was trying to guess. And I actually did get it, and I used 60-second exposures. And this is pretty close to the celestial equator again, and I'm dealing with crescent moon. And I was, with 60-second exposures, I was rejecting about half of the frames. So I actually had to go for about 2 or 3 hours before I got sufficient number of frames to set. But since the motion is so small, 3 hours, you really don't know, you can't see the trail of the object. And the result, there it is. At the tip of my little arrow there. This is a zoomed in, cropped section of the frame, of the actual frame, but it was actually there. The way I confirmed that, in the freeware application Surreal, there's a asteroid comet identification script. It also identifies the minor planets and dwarf planets, the brighter dwarf planets. And it indicated the position at the lower left, and which is that zoomed in area right there. Now, just to make sure that that really is it, I went into Stellarium, into that same region, and pulled up the Digital Sky Survey. And there's nothing there. So I would say that was correct. But I really, because of the moon, the following nights, it really wouldn't have worked out. The moon really would have washed it out completely. So I'm going to retry with a different object. With August, around August noon, Eris has a magnitude of 18.6. When you figure in air mass, it's going to be more around 19. But it's also going to be well placed along the meridian during the new moon.
I imaged Eris about a month after it was discovered.
Oh, really? Okay.
Yes. I'll have to see if I can dig that out.
It'll be interesting to see if the sea star can pick it up. The one thing the sea star can pick up some really faint stuff, but there's really limited scientific value because it's a color sensor. You know of any, are there any conversions for color sensors to photometry?
I doubt it because, you got each one of those colors are skimming fast.
Yep.
And so in order to get kind of an average of that, it would be pretty difficult because each object is going to have a different response to that color. So yeah, it's going to be tough to do, I think.
It'd be nice if ZWO would come up with a monochrome version of the sea star.
Yeah.
That would enable scientific imaging for masses.
And they got filters for it too,
Yeah.
right? They already have filters.
The other thing I'd like to see them add is the ability to specify through an input dial coordinates of an object, rather than having to
Yes.
scroll through the sky atlas trying to guess where.
That should be a real simple thing to do.
Yeah, it should be. It should be.
You can control it with, is it Atom drivers or something, whatever it is?
Yeah, there's
I think you
the.
control it with DNAR.
I've seen people control it with Nina, but you have to set it up on the, you have to not put it up on the network. It's kind of you have to go through a lot of hoops to do it.
They built it into the control interface somehow, I don't know, I sort of read on how that.
What do you use? You use copper?
No, I don't do it, I would just use a little app, I gotta have it to use it. So I haven't done that, I haven't heard that, but it totally works.
Yeah, the problem is, where I do my observe, where I set it up, I'd be too far from the router. I'd be using my laptop, which is Linux.
Yeah.
So that's not an option for me.
Yeah, I got you.
Would it work with anything that has, I think it's ASCOM drivers or what's the
ASCOM is strictly Windows.
Or, well, no, that's the other one.
Indy?
Maybe.
Indy?
Indy? I don't know.
It's one or the other, I don't recall.
Indy is what they use for, is the equivalent for Linux.
Linux, yes.
But it has far fewer drivers its support is pretty limited.
That's the real problem. Well, I mean, you got some great software, but you can't use it on a machine.
There's C-Star Alpaca
Yeah.
drivers,
That's a Windows, isn't it?
which is like, it's supposed to be like a more cross-platform ASCOM.
Mm.
Yeah. But, yeah, it would probably take some messing around to figure it out.
There was a guy that wrote a standalone interface app thing for it, and then they came out with the Alpaca drivers.
Mm.
Officially,
I'll have to look at that.
he kind of abandoned that project because it was basically weird.
The other thing that I thought about, just kind of thought about just today, is Supernova. Should be able to, some of the brighter Supernova, should be able to image those with the C-Star. I saw a Facebook post from a guy who had posted for the fairly recent bright supernovae that were within reach of the C-Star. That's another angle to
I got,
So that-
on the local galaxy by just random luck.
I took some pictures last year ago of the what's the one they're saying is going to go again? The one that does every 80 years.
Corona Borealis?
Yeah, Keep Road Borealis. I took some, reference
Yeah.
images
Yeah.
a year ago.
Yeah, I've been following that just about every month. I try to get a few more images of it, but
I'm still waiting.
that's still weird. I think Graham did mention that he thought that the amount of material that was drawing away from the one star to the other is reduced maybe because it's starting to reach a certain point, so that it won't go through the explosion stage. I don't know. He had something on it anyway. I'm not exactly sure what it was. And he made a prediction that it wouldn't go off. So maybe it will delay considerably. Yeah.
So far, it's been the case.
Well, thank you. That was very interesting. Anything else?
I think I'm still my 22 inch to get to see
Somebody would have to get like a very large truck to move that thing with me.
It's not as heavy as 4 points.
Sturdy.
Yeah,
So,
I looked at it, it's the IMX 462 is the
Oh,
top
462.
in the 50 anyway.
Okay, 462.
Okay, cool. I'll look that up. See what other cameras use that.
Some other stuff guys use it, I know, but I don't think it's not as common.
It's not.
Something that should be more common.
It's an amazing little ship, though.
Yeah.
Incredible sensitive.
Well, but their application of that chip was pretty novel. They did a really good job in setting the parameters up and using that chip to get the results that they got.
Mhm.
They knew